It's 10th grade chemistry paper. It's a model paper, and here we are doing long question answers or your subjective part. The first question here is state law of mass action, drive Kc expression for the following reaction. The reaction might given to you. If it is, then you have to drive the expression for that particular reaction, and if it is not, then you can pick any of the reaction or any general reaction. So law of mass action states that rate of a reaction is directly proportional to the active masses. So that simply means that rate of forward reaction will directly proportional to the active masses of reactant, and rate of backward reaction will be directly proportional to the active masses of the products. So rate of reaction means speed of reaction. And the term active mass means you are taking concentration in mole per decimeter cube, so you have to mention the unit here. Then we have an equation. Always remember this thing, that we need a balance equation for the Kc generation expression. So we just whatever we stated in the definition, we need to write it down in the expression form and then in the equation. So rate of forward reaction is directly proportional to hydrochloric acid power 4, because 4 molecules are involved here in the balanced equation and 1 oxygen molecule. And this is a relation, and if you want to convert the relation into an equation, so you have to put the constant here. So rate of forward reaction is equal to Kf, and the remaining thing is still there. The rate of reverse reaction is obviously directly proportional to the active masses of chlorine and water, and both have power square, and you convert it into an equation by putting just equal sign and Kr with the constant. As we all know that whenever the equilibrium attains, that means the rate of forward reaction and backward reaction will be equal. That simply means Rf is equal to R stands for reversible reaction, F stands for forward reaction. So you just need to equalize both of them and took the values which they are equalizing in the previous equation and equalize it. And Kf divided by Kr, we know that if there is, if you switch something around the equal sign, that the numerator converted into denominator and denominator converted into numerator, and plus into minus and minus into plus, but one action at one time. So here we have Kf over Kr is equal to product ratio divided by reactant ratio, and here we generate the Kc sign or Kc expression, sorry. And simply you can determine the unit if it's a question, so you just need to put mole per decimeter cube instead of all of the product or reactants given there. The next question here is, we have this 4 hydrochloric acid and oxygen and 2 chlorine and 2 water. This one is the equation which is given with the previous. This is just the problem, the typing. So this is the equation given to you in the paper. The third question here is, identify Laurie-Bronsted acid and bases in the following reactions. Reactions are given to you. What you need to identify is Laurie-Bronsted acid and base. So first of all, you must know that what exactly the concept between this Laurie-Bronsted term is. So acids are those which have ability to donate the proton, and bases are those which have ability to accept the proton. So here we have the HCO3 bicarbonate ion, and water is there and it's reacting and giving you carbonate CO3 minus 2, so hydrogen is released from it. So those who released hydrogen ion, that is considered as Laurie acid. So your bicarbonate is Laurie acid here, and water absorb that proton, so it is considered as Laurie-Bronsted base. And then we have ammonia reacting with nitric acid, and it's forming ammonium nitrate here. And so what exactly happens here, he broke it down into an equation form. Ammonia, nitrogen has a lone pair, it take hydrogen H positive from the nitric acid. So nitric acid is providing H positive, so it is you can say acceptance of proton is by ammonia. So proton acceptor is a base and proton donor is an acid. So nitric acid is a Laurie-Bronsted acid and ammonia is a Laurie-Bronsted base. Then we have BF3, and fluoride is there and it is forming BF4. And here we have लॉरी ब्रॉन्स्टेड एसिड बेस कॉन्सेप्ट आप फॉलो नहीं कर सकते. Simple with the reason is that there is not the working, we are not working with H positive, and there is not H positive here. So we have fluoridine, and we know fluoridine have extra electrons, so you can share the electron. So we can explain it with the help of Lewis acid and base. So fluoride will be Lewis base and BF will be a Lewis acid. Then we have the next one. We have acetic acid, and it is reacting with water, and acetylene is formed, and H2 positive is formed. So water is absorbing H positive, so it is a Lowry base, and your acetic acid is donating the H positive, so it is Lowry acid. So what you really need to do is to read the equations carefully, that which one is giving the proton or which one is accepting the proton. The next is what is hard water. Hard water is the one which have excess of calcium and magnesium ions and excess amount of salt, or it doesn't form leather with soap. So this is your first part, and there he needs you to mention how you remove the temporary hardness of water. So temporary hardness हम remove कर सकते हैं simply boiling से remove कर सकते हैं, slate lime use करके remove कर सकते हैं. These both methods you may use. So just simply define a few lines about the removal method, and just describe that which type of ions are present and how you remove those ions and all that stuff. And by adding slate lime, we have Clark's method is here, and just you have to add the slate lime into your system, and obviously your bicarbonate converted into carbonate, and that is not soluble, so it will be removed from the system. So these two methods you can explain here. Then the next question here is, what are nucleic acids? Describe structure and function of DNA. So nucleic acid, the definition is there. So nucleic acid, it's a complex organic compounds which are present in your DNA and RNA. They have nucleotides, they have long chains through which they're formed, and the basic three components here are nitrogenous base, their pentose sugar, that pentose sugar has been pentamine 5, so it's a 5 carbon sugar structure, and phosphate group. And describe the structure and function of DNA, so you have to define it as well. So DNA is your deoxyribonucleic acid जो एक twisted strands की form में present होता है, spiral forms में present होता है, and it contains deoxyribose sugar, and that is the difference between DNA and RNA, that DNA have deoxyribose sugar and your RNA have ribose sugar. And these two strands which are held together, that is due to hydrogen bond. And this is all, you can draw the structure as well, and then their functions, information storage, genetic information जो आपके पास आपकी body से next body में transfer होती है, that is through the DNA system and all that stuff. Then we have a functional group. What is functional group? So you have to define it. Any particular atom or group of atoms which generate certain specific properties in your organic compound or in your carbon chain, that is considered as functional group. And you have to identify the functional group in the compounds. We have CH3, C double bond, OCH3. So that means we have carbonyl group, and both sides we have carbon chain, so that is ketone. And there is no need to name it because they didn't ask for, so that is more than enough. Then the next one is CH3C double bond OOH. Here we again have carbonyl group, but one end is fixed with OH, so it is carboxylic acids, carboxylic group. Then we have C double bond OH is fixed on one side, and on the other side we have CH3 carbon chain, so that is aldehyde. And again, these all three have carbonyl groups. One side fixed with hydrogen, both sides have carbon chain, one side fixed with hydroxide. So this is how you differentiate it and remember it. Okay, now the next part here is, how will you convert propene into propyne? Name the product formed in each step. So from where you're starting, that is a double bond chain, and you need to convert it into a triple bond chain. So obviously you need to remove hydrogen here. So you can simply you can do dehydrogenation here. And the other method here he followed is that you are converting your system or into First of all, you are halogenation is happened here. You are removing the double bond by adding halogen on both the atoms which have their double bond in the presence of carbon tetrachloride. So here we have bromine on both sides, and then with the help of alcoholic KOH, what we do, we remove bromine first. Hydrogen bromide will be removed and one bromine is still here. So in the next phase we remove the second bromine, and that it converts into propine. So across the bond it is HBr will be removed, so one hydrogen from here, and on the other carbon the bromine will be removed. So hydrogen bromide will be removed from the system, and that will produce triple bond in your system. And remember, we can't use aqueous KOH here. We only need to use alcoholic KOH, because on the other because there is no need to introduce hydroxyl group here in the system. And that's all with your first set model set paper of 10th grade chemistry. Thank you.